math enthusiasts, welcome back to your channel, your go-to destination for unraveling the mysteries of mathematics. I'm Ziba, and today we are diving into the fascinating world of finding the domain and range of various functions. But before we jump into the heart of today's topic, let's quickly recap what domain and range are all about. Just a quick recap from the first video on the series. Remember, we started with the function, domain, and range, and the definition. We said that we have, you can take a look at the function as a machine with an input and an output, with the function does an operation or a process on the input. So input is x or independent variable, and the y is the dependent variable. And the function usually noted with f is the operation or rule. Okay, so now let's take a look at these graphs. So this is your x, this is your y, and I want to define a function using this one. So a function actually relates each element of a set with exactly one element of another set. So as you can see, this one is related to this one, and this here, the arrow, is actually the operation. This one to this one, so this is input, this is output. And as you can see here, two different elements are related to one, they produce one output or one y value. So again, x is input, y is output, and the arrow, it's the actually operation. Okay, now that we have refreshed our memories, let's roll up our sleeves and tackle the exciting challenge of finding the domain and range for various functions. Whether you're using or dealing with linear function, quadratic function, or higher orders, or even more complex ones, the principles remain the same. Remember, guys, we talked about the possible value. We put a condition. So let's elaborate on it a little bit more. So let's say if our function is f of x equals, so here we have some restriction. We know that, so all the problem is asking you to find what values of x can be plugged into the function. This is useful to know since some functions have got limitation. And in other words, there are only some permissible values which you can use as an input. For instance, consider this function f of x is equal 1 over x. We know that when we have a fraction, the denominator can never be 0. In other words, we can never divide by 0. So here, our domain cannot include the value of 0. However, all the other values can be plugged in and the function can be defined for them. So once more, here your domain, if I want to show it with d domain of f, or some people, they just show it with d of f, okay? So it is all the real numbers except 0, because if you put 0 as x is in the denominator, it is not defined. So x as a 0, it's a limitation. Okay, so if I want to write it as a bullet point for you, there are 3 limitations: dividing by 0, negative square root, and negative logs, because you know that the square root can never be exactly a negative value. And remember the log, under log, we just mentioned that there is no such thing as negative logs. So let me write it down. So there are 3 situations which are not permissible. So first of all, the far most important, it's dividing by 0. Remember, your denominator can never be 0. So this is the first one. The second one is negative square root, okay? And the third one is negative log. These can never happen. Like these are your limitation, okay? So whenever you want to define the domain of a function, you have to take care of these three issues. Now, how can we write down the domain? There are two ways, or there are two or three common ways, like this one, which I just showed you, which is called the set notation, or the other one, it's called the interval notation. So if I want to write this down as well, there are two ways you can show the domain, okay? One of them is the set notation, and the other one is interval notation, okay? Interval notation. It's up to you which method you want to use, unless the question asks you specifically which method to use. Okay, now let's talk about an example. So here I have a function g of x. So you have a function, the name is g, and your variable is x, and it is 6x minus 2 divided by 3x minus 4. Okay, so this is your function, and now the question is asking you to find the domain. Okay, remember guys, what I just mentioned here, your denominator can never be 0. So any other values can be, for x, can be plugged in, except the values which makes your denominator as 0. So let's find the values which makes your denominator 0. So x would be 4 divided by 3. So any value for x is acceptable except 4 over 3. So this is how you can write it. Your domain is all the real numbers except 4 divided by 3. This is how you can show your domain. Okay, now let's do another example. So here, let's say h of x is square root of x minus 6. Okay, so remember, here your function is h, your independent variable or your input is x, and the operation, it's x, your input, it's subtracted from, is actually 6 is subtracted from your input, and then the square root is taken. Here, if you want to find the domain, you have to make sure that under the square root, it's always greater or equal to 0, because it can never be negative. So from here, the value of x would be greater than 6. Okay, so here, how you can show your domain, you could say that 6 included all the way to plus infinity. Or if you want to show the other way, the graphical way, so this is your x-axis, so this is your 0, this is your plus infinity, this is your negative infinity, and let's say the plus 6 would be somewhere around here, and moving toward plus infinity, right? So these are all the acceptable values, and then is 6 included or not? It is. So you also highlight the circle. So all the values from 6 all the way to plus infinity are permissible values. Now let's do another question. Here we have the function m of x, and we have 2x divided by 2x minus 2. Here the only limitation that we have is that the denominator, we have to exclude all the values which makes the denominator 0. The value which makes it 0, it's 1. So your domain, it could be all the real numbers except negative. So your domain, it's all the real numbers except plus 1. Okay, now let's do another example. Here, g of x is equal to x squared minus 4. So you have a square root, and then underneath you have a quadratic function. So you have to see x squared minus 4 must be or greater or equal to 0. In order to find what values makes it 0, we have to find the roots. Okay, so I can find the roots here. So remember, x could either be +2 or -2. These two values makes x squared minus 4 0. Okay, so let me show you the graphical. If this is 0, this is -2, and this is +2, at these 2 points exactly, your value, x squared minus 4, would be 0. But how about this portion, or this portion? We have to figure it out. So the easiest way for you guys to figure it out is just by picking a number in this interval. So let's say I pick number 3 and I plug in 3 in here. So that would be 9 minus 4, which is positive. So any number in here, okay, would be positive, right? And then it's acceptable because we are looking for whatever values makes our square root either positive or greater than 0. So this is also, this circle, which is exactly as +2, is also included because exactly at 2 our expression is 0. But let's pick a number in this area from -2 to +2. Let's pick 0. Okay, and see if in this area our expression would be positive or negative. So if I plug in 0, that would be -4, which is not acceptable for us. Remember, guys, we are looking only for values which makes the square root positive, right? So here in this area, whatever we put, it would be negative, and it is not the acceptable area. Okay, so how about values less than -2? Let's pick -4 and plug it in here and see how much is it. So it would be 16 minus 4, which is 12. So any values in here would also make it positive, and this is the value that we are looking for. How about -2? Again, -2 is also included because exactly at -2, our expression is actually 0, and this is what we are looking for. Okay, so these are the acceptable values. This is the graphical, representation. Now let me show you how we can show this by set. So here, in order to find the domain, okay, the domain would be, okay, domain of your function, which is g. So it's all the negative numbers all the way to -2, negative numbers all the way to -2. Okay, so -2 is included, and right from +2 all the way to positive infinity. You can either use this one or this one to show all the accepted values or the domain for your function. Let's do another example. I'll do another exciting, sometimes it could be a combination of these. So f of x, so your function would be x minus 4 in here, and then 2x minus 6 in here. Okay, so here, remember, guys, we have how many limitation? Yes, correct. There are 2 limitations. First of all, our denominator should not be 0. So we have to find the values which make it 0 and exclude it. So this is a value which is troublesome. Okay. Another limitation comes from the square root, which is x minus 4 must be greater than 0. Okay. So x must be greater or equal to 4. Okay, so if I want to do the graphical representation, I have 0, negative infinity, plus infinity, then I have 3 and 4. Okay, so 3, it's not included, but 4 is included. Okay, so all the values greater than 4, okay, and then the other condition is that the x should not be 3. So, okay, so if I want to do an intersection of these two, the final domain will be, yes, from 4 all the way to possible infinity. Another way of finding the domain and range would be by graphical. Like, first of all, you graph your function, and then from the graph, you could say what is the domain and range. So let's assume this is your function, okay, whatever it is, okay. I don't know at this point, I don't care about the equation. What I know, this is the function, this is the graph, and I want to find the domain. Remember, guys, the domain is related to the x values. So this, we have to see where does your graph reflect on the x-axis. So all these values, right, are your domain. Okay, so these are all the acceptable values, right? These are your domain. And what about the range? Remember, yes, your range is related to the y value. So from here, okay, let's assuming here, and then this one would be here. So this is your range. So remember, guys, whenever you have a function, another way of algebra would be by graphing your function, and from your function talking about the domain and range. Reflect it on the x and y axis and find it. Let's do another one. Let's see if we have a line, okay? If I have, this is the x, this is the y, and here I have a line, okay? This is one simple line, okay? This is a linear function, or this is your line, okay? So the function, it's y equals to x. What is the domain and what is the range? Remember, guys, for the domain, we have to reflect it on the x-axis, okay? So if I reflect, it starts from here all the way to, should I stop here or should I continue? Okay, yeah, for sure we have to continue, because you know that this line goes to infinity. It doesn't stop. So if it goes to infinity and I want to reflect it on the x-axis, it will also be all the positive x values. And from the negative end, it's also, if you reflect it on the x-axis, it will contain all the negative values. So you could say that your domain, right, it's all the real numbers. And how about the range? For range is also the same thing, because the line doesn't stop, it goes to infinity. So if you reflect it on the y-axis, your range, it's also all the real numbers. Let's do another example. Here I'll do a complex kind of function, x and y. Now your function is something like this. So let's say going from this to here, okay? You have graphed it, and this is it. So now the next step is finding the, first of all, let's focus on the domain. So if your function, right, let's say if this is specific function ends here and here, okay, and doesn't go into infinity, that means if I reflect it on the x-axis, your domain would be from here all the way to here. These are all the accepted, right? These are all the accepted x values. This is your domain. And if I want to talk about the range, so if I reflect it again here on the y-axis, it would be all the way from here to here. Okay, this is your range. So as you can see, if you have the graph, it's really easy to find the domain and range. Otherwise, you have to use algebra. Now I want to give you a table about the domain and range of the most famous functions in the mathematics. So the first function we will talk about, it's a, yes, let's call it polynomial. So a polynomial function, remember guys, when we define polynomial under algebra, they could be like anything, like they could be any expression with any order. So either linear, quadratic, cubic, or etc. Right? So it could be linear, right? Quadratic, cubic, or even higher order. So, okay, any order. So for these ones, the domain, it's all the real numbers. The next one, which is a square root function here, like, just to give you an example, like this one. So remember guys, we said that it should never be negative. So all the values which makes the expression greater or equal to 0. Now, talking about the next type of function you will get, exponential function, the domain, it's also 0. Okay, the fourth type, it's the logarithmic function, right? Here, if you remember, we had a limitation. So the x shouldn't be 0. So it includes all the x's greater than 0, not including 0. The last one, which is the rational function, if you remember these functions, they are in the form of fraction, and each fraction could be a polynomial. Here, to find the domain, you have to set the denominator to 0. Okay, so I just put you put denominator. Okay, denominator to 0, to 0, and exclude these values, right? But just be on the hunt if there are any kind of other, limitations. So sometimes it could be a rational function, but in the numerator, they might give you a square root. In that case, you have to consider the other limitation, which comes from the square root. Okay, and then at the end, you have to find the intersection of these two. Now, talking about the range, if you remember, the range of a function is the set of all its output, right? So, let's see what are the range of these famous functions. So again, if we talk about the polynomial, the domain is R, the range is also the R. Okay, now for quadratic function, I have to, like here, remember when we talked about the domain, I included linear, quadratic, and cubic, but here I just want to open a side note for quadratic, because if you remember, the quadratic, it's a U-shaped, right? So this vertex could be either at 0, 0, or it could be shifted up or shifted down, all right? So your range would be from vertex, okay, all the way up, or from vertex all the way down, right? Depending on the shape. If it's upward, it would be all the way up. If it's downward, it will be all the way down. Okay, now the range of a square. Okay, the next one. Okay, talking about the square root function, the range, it's again greater than the y, it's greater or equal to 0. Now the next one is range of an exponential. Here the range of the exponential is greater than 0, not including 0. The range of the logarithm, it's all the real numbers. Now, to find the range of a rational function, there is one way you can do it. So you solve for x and set the denominator. Solve for x and set the denominator against 0, right? This is a summary of finding the range and domain of a function. This is a very big topic, extensively big topic. I cannot just accommodate it in one specific video, but here so far, this video should have given you an idea of how to find the domain and range of the most famous, um, function. If you come across a function which is not, look familiar to you, you can easily graph it, and by looking at the graph, you can guess the domain and range. Otherwise, please follow my channel for more videos. There would be some videos with the title practice time, in which I will only solve equations, and during solving the problems, I will explain the concept as well. Don't forget to subscribe to my channel and follow me for more videos. See you soon.